OpenAI's super alignment team just released a paper called Prover-Verifier Game Improve Legibility of LLM Outputs. In plain words, legibility means the output of the LLM are easy to understand. This is from the super alignment team. Super alignment is a concept they previously proposed so that they can achieve weak to strong generation. They want to use a weaker model to supervise a stronger model that's shown on the right. Traditionally, we human label data and train the weak models, and this is not very scalable because up to some point, the super intelligence will be smarter than humans. We won't be able to supervise those models anymore. That's why they want to propose an idea that use a weaker model to supervise stronger model. So in this paper, they provide an approach to achieve this weak to strong. The verifier is a weaker model that can verify the correctness of the stronger model, which is a prover. A problem with a strong model is that up to some point, the strong model's output will be very hard to understand. Like in this example, the human asked the question like how to write a fast sorting algorithm. The superhuman AI outputs something uninterpretable or unlegible by the human. And so this looks like it's a quick sort algorithm, but it's very hard to understand. So the structure OpenAI proposed is called prover and verifier. So they train this model multi-rounds iteratively. There are two phases. The first phase is a verifier training. The second one is prover training. So when you're training the verifier, the weak verifier wants to predict the correctness of solutions generated by the prover. And the prover, they train two prover model. One of the prover model is a helpful role. They want to generate correct solutions that are easy to understand. And there's also another sneaky role that generate incorrect solution that also score high according to the verifier. They call scoring because the verifier is a score model. So it will give a score to the solution that very high if the it thinks the solution is correct, and very low if it thinks the solution is incorrect. Basically, when you train the verifier model, it's going to contrast, do a pairwise training. So the pair is the one correct answer from the helpful row and another incorrect answer from the sneaky row. They want to promote the score on the helpful row and decrease that on the sneaky row. The prover training is through PPO. So their key finding is that they're able to increase the accuracy of the model without sacrificing legibility. So traditionally, if you make the model more accurate, the legibility will be very low. Like on the y-axis, it's the accuracy by the human evaluator. The answer generated by the strong model is very hard to understand by the human evaluator. But through this training process, they're able to train a model that can still be understood by the human while the model accuracy is improved, which is really surprising. Because this shows that a weaker model and the solutions that are legible to the weaker model is also legible to humans. So this is a example given by the trained model. Shauna's father is 5 times older than Shauna. Shauna is currently 3 times as old as Aliyah. Aliyah is 3 years old. How old is Shauna's father? Like, without any training, the model would give very straightforward answer and very short answer. Like, it directly gave out the answer that Shauna is currently 9 years old. That's 3 times 3, but it doesn't explain why it's 3 times 3. But after some training, you can see that the answer is much longer and more interpretable. It says first, in the question, it says Aliyah is 3 years old. And to be able to calculate Shauna's current age, it's 3 times as old as Aliyah. So the answer is 3 by 3 is 9. So it's more legible.